Alrighty, why don't we get started since it's 3:05. So I think everyone's coming back from a lunch break or might still be having their lunch. Um, so just to kind of give everyone a brief overview. So each day this week, we'll be having a different sponsor give a presentation to WebLab. The sponsors are really the ones who help keep WebLab running each and every year. And so we're greatly appreciative that they're here to join us and give us a lecture. So today is going to be our first lecture, and Carlos is our presenter from Appian, and then Juliet Wilson is also here. She's the recruiter, and I think she'll say something at the end about potential recruiting or internship and full-time opportunities. But with that, Carlos, I can hand it over to you, and you can get started.
Sounds good. Let me make sure this sound. So if you don't mind confirming that you can see my screen, and I should be able to see. You can confirm that you're seeing my screen. Okay. So hi everyone. Thank you very much for being with us today. I'm here today coming from Appian, and I want to teach you a little bit about how to build a smart web app using machine learning. I know that you're in this exciting competition to build a web app, and what I would like to do is to give you a little bit of background in the machine learning, and specifically teach you how to add machine learning into your application, the same way that we're doing it at Appian. You can follow the slides at any time. I put it in the chat here. I'm gonna put them again. It might be easier if you have the slides to follow along. I'll share code and we'll try to work things together. At any point, feel free to ask any questions in the chat. So the application we're gonna be building, it's a very simple one that lets you identify a digit. This is a classic data set in machine learning. And you can see what we're going to be building together here. So if you go to that link, it will work. It should work on your phone, on iPad, or in your browser. So if you can draw something there, and you can see that it's picking up a digit. I think it's a little bit of fun to play with. Sometimes it works, sometimes it fails. And so what a couple of interesting things here is that you can see it's just plain HTML with JavaScript inside. If you see the source, you see everything that you need to reproduce this. The only thing I'm missing, the model. And I'll teach you how to put a model into this web application. You can also have directly the source here. You can go to GitHub, and you have the HTML CSS, and you have also the JavaScript needed to run that machine learning model that we're going to be building it together. The agenda might be a little bit packed. I'll try to go quick, and I want to leave a couple of minutes at the end for Juliet. Yeah, what I'm going to be doing is I want to introduce a little bit of myself and Appian. I want to give you a high-level overview of what's machine learning. I know that you're in your first class at MIT, so I'm just going to give a high-level overview of machine learning, and then teach you how to train a very simple neural network. It's actually easier than that way you might think. And once we have that model, what we're going to be doing is we're going to be loading that machine learning model in JavaScript. The same way that you can load a library in JavaScript, you can also load your machine learning model. And the advantage that we have, that I'm going to be teaching you, is that typically how things work is that if you want to run a machine learning model, you have to have a separate service or a separate task. And in this case, everything is 100% in JavaScript. So what that means is that if you inspect the network connections here, whenever I'm doing a prediction, all the prediction is staying within the browser. So this should be really advantageous to you in your competition. I also want to teach you how I'm using HTML5 canvas to draw, how we're drawing the digits, and show you how you can leverage GitHub pages to deploy HTML for free. And as a stretch, if we actually happen to have time, there's another app that I believe is even more interesting, but more complicated, where we deploy a more complicated machine learning algorithm called AlphaZero in a web app. So let's get it started. So my name is Carlos Aguayo. I'm a Senior Director of Software Development at Appian. I've been there for a while. It's now 16 years. It's going to be 16 years in March. And I'm also a master's graduate in Georgia Tech. I did a machine learning specialization there. You can find contact information there. Feel free to ping me, email me, ask me questions. I love to talk to folks. And like I said, I come from Appian. Appian, it's a company that's, we're changing the way businesses implement software, and we're revolutionizing the industry. We're located in, our HQ is in DC. However, with this pandemic, basically our workforce, all of us are remote, as you would expect. And I want to spend a minute or two explaining to you the business that we're in and why Appian has had so much success in the last few years, and why we have so much potential for the upcoming ones. So Appian is in a business called low code, and the way to think about it is, picture pretty much every company in the world. Every company in the world requires software to run their businesses. And in here, I have five example companies. Hopefully, perhaps you're familiar with a few of them or most of them. So we'll start with Pfizer. I mean, pretty much all of you would have heard of Pfizer in the news. I mean, they're the ones leading the vaccine. But another, for example, company would be Dallas Fort Worth Airport. Perhaps you have flown at. Is a leader in leasing trucks for business purposes in the US. So perhaps you're familiar with U-Haul, where you can rent a truck whenever you move into an apartment or into a house. If you're a business, you're going to be renting from Ryder. You're also familiar perhaps with College Board. Pretty much if you're entering into graduate or undergrad, you have to go to College Board, or Santander, one of the biggest banks in the world. If you think about all those companies, they have their expertise in their own vertical. Like, for example, Pfizer is a pharmaceutical company. Ryder, like I said, is a truck company. But to run their businesses, they need software that is tailored for their needs, that they just cannot go and pick up from a store. So a simple example is, if we go back to Ryder, imagine that you're a company. You have to lease and rent trucks. So one of the easiest things to think of is that you need software that lets you check in and check out your trucks. So if you're an employee in Ryder, you have to come up with that software. There's certainly not that software off the shelves where you can just go and buy it. You have to build the software. But now, something that perhaps you're learning so far is that building software, writing software, is actually very hard. When you start thinking about mission critical, there are many things that you have to consider. So I'll have to follow my notes. Like, for example, a very simple thing is when you're writing your application, you have to ensure it works in all browsers, even for your competition. Perhaps you'll have to check that it works in Chrome and Firefox and Safari, and it might not be so difficult, but then you have to also check perhaps IE and others. Then your application should also work in mobile phones. So you would expect that it has an iOS app and an Android app. It has to be secure, it has to be scalable. It should work in other languages other than English. I think many of us speak many other languages, and our customers are not going to be only in the US. An interesting aspect is that it should be accessible for a user with disabilities. many of these companies actually expect all those things for granted. And building software with these requirements is actually really, really hard. And this is where Appian is extremely successful. We provide a platform that we call low code, where these customers can build their custom applications without having a huge software engineer team to build and support those aspects. I'll cut the introduction short. I can answer more questions, and perhaps Julie wants to say a few words at the end. We're also obviously hiring. COVID has not stopped us. The contrary, has even proved how important a company like Appian is. We still have exciting interns and full-time opportunities. So with that said, I'm gonna get started into what is machine learning. Bear with me, I'm gonna start extremely simple in case that you have never heard about machine learning at works. And the way I would like to do it is through an example. So that this example will show you the main characteristics of machine learning. So imagine that I give you a Cartesian plane and I show you a dot. I give you information about the dot. I give you the X and Y position, and I ask you to predict or tell me what's the color of this point. And the only hint that I would give you is that the color, it's either pink or blue. If I ask you that question, will you be able to answer it? So in here, the question is, well, not really. I mean, you don't know much, but things will change if all of a sudden I give you data or experience. If now you see at this a chart, things start to look really different. If I'm asking you about this dot, and you're realizing that it's very close to all these other blue dots and far from all of these pink dots, your brain will start doing something very remarkable. Immediately will tell you that it's blue. And if I ask you, how do you do that? It's certainly not magic. I mean, your brain did something very quick. What your brain did is that it realized, well, this point is very close to other blue points. Therefore, it's blue and not pink. And what you just did is you used a machine learning algorithm that is called K nearest neighbors. That is actually one of the simplest but effective machine learning algorithms. Believe it or not, it is actually widely used. And the couple of things that you should know from here that represent machine learning are the following. So first of all, notice that in order to run a prediction, you needed data. In machine learning, you need data, and from there, you can draw conclusions or predictions. So you needed data to know that this pointer was blue and not pink. That's the first thing. Without data, basically you have nothing. Another interesting thing is that machine learning is not magic. It cannot create inferences out of thin air. What I mean by that is that if I would put another dot, perhaps say, the question is, how do you know that brains implement k nearest neighbors or even any algorithms that bear similarity to it? Well, I don't know if the brain implements that, but what we do know is that, for example, if I would go and have surveyed most of you and we have asked you if the dot is blue or pink, I would strongly bet that the high majority of you said that it was blue, and that the answer was because it was near these blue dots. In a couple of minutes, I'm going to talk about something called neural networks that takes inspiration from the brain. At the same time, obviously, I'll admit that in this particular area of machine learning, the interest that many people have is to be able to run predictions against databases. In these particular examples, our interest is not necessarily to find out how the brain is modeling things. There's obviously other areas that does that, but not right now. That's actually a great question. Thank you. So the other aspect for machine learning in here is that if I would put perhaps a dot up here, perhaps you would be confused. You could say, well, I mean, I don't know if it's pink, if it's blue. Certainly you wouldn't be able to say or predict that that dot is orange, red, or yellow, because in the data, the only things that you have seen are blue dots and pink dots. An example about that is, imagine that I give you a data set with voices of adult people, male and female, and then I try to give you the voice of a boy or a girl. I'm not able to, the data set perhaps could identify the person as a guy or as a girl, but it no longer can predict if it's an adult or a child, because in the data set, we have not taught them at that. In other words, while you can run inferences about the classes that you have, you cannot take new classes. That's another restriction where something is not intuitive in machine learning. Now, the last thing I will tell you in machine learning is that regardless the algorithm that you're using, ultimately what you want to do is that you want to map the set of inputs and into a function to predict an output. So in this case, the input is the x and y, and what we're creating is a function that will map into a blue or a pink into a pink dot. And like I mentioned, that's k nearest neighbor. Now let's move into something more interesting, which is called neural networks. And neural networks have just a fancy name. I will explain them again through an example. So imagine that you have a very important decision to make tonight. I'll explain the low code. Thank you for your questions. Low code, no code, I'll explain them at the end of the presentation. Imagine that you have an important decision to make, and there's a party tonight, and you want to figure out if you want to go out. And to make that decision, one could say, okay, there's different factors that are involved to make a decision. Perhaps, for example, perhaps an important aspect is if you can wake up late tomorrow. Another aspect, perhaps you have a crush and you want to, and if the person is there or not, that would affect your decision. Perhaps you want to know if your friends are there. There are many aspects that can affect your decision. And neural networks is just a weighted decision. The way you're going to make this decision is through a weighted, give weights to each factor in your equation. And let's say for this particular example, that if your crush is there, that takes a value of 10. I mean, you take that as a very important. If your friend is there, it's a 7. If you can wake up late tomorrow, that's not as important as the other two, and you give it a value of 5, and so on. And what you do is that imagine that you know the person that you like is going to be there, and everything else is not going to happen. So your friends are not there. You cannot wake up late tomorrow. You might have plans, anything else. But only thing you know is that your crush is there, and because your crush is there, the value of this sum is going to be 10. And for some reason, you decided that if the sum is 10 or higher, you're going to be there. So in this case, your crush is there. So automatically, yes, you're going to be at the party. And that's how you decide. This is actually a great question of when there are many things to consider, would the weights still be set manually? Great question. In this particular example, I'm setting the weights manually. In reality, coming out with the weights, it's called training. That's what when we say that we're training a neural network, we're finding the best weights for we're finding the best weights that map the inputs to the outputs, and I'll provide an example for in a bit. But for now, let's assume that I already know where those weights are coming from. I'm trying to show how does a simple neural network work. So let's move into another example. So everything else is a no, and the only thing is a yes is that I can wake up late. So we agreed that the value for waking up late is a 5. So that 5 is below our threshold. So no, we're gonna take a rain check and we're gonna skip the party. But now, Imagine that we can wake up late and also our friend is going to be there. Perhaps no crash, perhaps we do have plans, perhaps it's not a new party, but our friend is there and we can wake up late. So 7 plus 5 is 12, and that goes above our threshold. And so, yes, we'll be at the party. So what you should be getting right now is that all that we're doing is called a weighted decision. We have a set of inputs with certain weights that will figure out where they're coming from. And as long as they cross a certain threshold, we make a decision. That is what is called a perceptron or a neural network. This takes inspiration from what an actual neuron in the brain does. Um, in the idea is that in our brains, each of our neurons take inputs and they make a decision and take an electrical output, the same way that we're doing a weighted decision here. I wouldn't read too much into the biological similarities. All that you need to do is that you're making a weighted decision. And now the question is, okay, this is a very simple thing. How do you make it strong? The way that you make it strong is you just put them together. So this is an example of a more real neural network. And what you're seeing here, it's easier to see by an example. So if we overlap the weighted decision that we're making before, overlap it here, and you can see how we were doing the sum before. We take all our inputs and put it into a sum. Each node in here is doing the exact same thing. So this sum is the one that we had all the weights here. But for example, and it has certain weights in here. If we take the neuron that it's beneath it, it will have different weights, but it's making the same mathematical operation of just doing a weighted decision. And then the output of this sum becomes the input to another layer. And when you take the input to another layer and then do the same process again, in the end, you will have take a decision. What is really impressive from this thing is that um, there's a mathematical theorem that shows that the neural networks can map any possible mathematical function. So when you think about it, it's actually very, very impressive. Imagine any mathematical function in the world. And technically, this paper proves that you can write a neural network that will model that function. That's why neural networks are so popular. The caveat is that, as always, those papers prove that it's possible. They don't show you how you go ahead and do it. And the challenge, the reason why neural networks have become so popular in the last few years is because we have found ways to better train them in a more efficient way and faster. However, neural networks have existed actually for the last 50 years. So now, moving on, so how we're gonna classify digits. So like I said before, we need, well, actually before that, so I will try to go quick for sake of time. Here, there's a blog post that I have with more information about the process that we're gonna be following. It should be helpful to you if you want to follow along or know more details or reproduce it in your case. I will answer the question, however, this is an important one. There's a question, is a goal sum like 10 in the example also determined by training, or is it decided manually? It's a great question. In reality, what happens is that the answer straight up is decided by training. In reality, the threshold is always 0. And what happens is that there's an extra neuron that is not necessarily an input that is called the bias. So imagine that that the weight, that the threshold is actually 10. The way that we're going to set it 0 is that we put another with a weight of 10, right? So when we put it as minus 10, that imagine always set to 1, that will make the threshold automatically to 0. There's another question, do more hidden layers in the neural network lead to better algorithms? So when you add more layers, What you're making possible is that you're making the equation, next one. You're giving more power to the equation, but you're not necessarily making it better. A simple way to explain it is, imagine, forget neural networks for a second, and imagine that that you're trying to predict. You have, let's go back here. Imagine that you have the chart, and you have several dots along the in your chart, and you try to determine a model that represents those dots. And imagine that those dots, the model behind it is just a straight line. Right? So if you have a straight line, the best model that represent that will be y equals to x plus mx x plus b, right? So you're representing a line. Now, if the model is actually say a higher order equation, the higher the order equation, sometimes the better that you will represent that line. However, if the model, for example, is very simple, say it's a straight line, and you are using a model of degree 10 or 20, right? The model perhaps will be really good at following that model, but perhaps it will start picking up too much noise, or where there are dots that you're not where you have not seen. In those, when you extrapolate it, you're gonna have terrible results. It's the same case when so it's the same case here. The more hidden layers that you're adding, the more complexity you're giving to your algorithm. And technically, yes, it will be better at predicting a better model, but at the same time, it might not be the same case. Um, so how we're going to be predicting digits? Overfitting. Yes, the example I mentioned, it's called overfitting, or there's an alternative of underfitting if we wouldn't have enough hidden layers. There's a link here with a blog post that shows the steps that we're going to be going through. Like I said before, to have good machine learning models, you first need to start with good data. So the way that we're going to predict a digit is that we're going to be using a data set. So the MNIST data set is the textbook example data set for machine learning. And what this data set is a set of 60,000 training images. So it's digits of 28 by 28 pixels in grayscale. So it's supposed to be a toy data set for testing purposes. And what we're going to be doing here is I'm going to keep things extremely simple. The inputs to this neural network is going to be each pixel in the image. So you have an image of 28 by 28. Imagine that that 2D data set, we just flatten it into a 1D array. So we have 28 by 28, that's 700 and something. And those become the input into this neural network. At the end, we're going to have an output layer. So an output layer in here, for example, will say if a character is 7, or we're going to have one output for each possible number. And I'll show you that more in a bit. So whenever we activate one of these neurons, it's going to tell us if we're identifying a 0 or 1 or a 2. And the way that we're going to train that model is that we're going to be using a Python notebook in Google Colab. Connect. And I want to give you a very quick introduction about the Python notebooks. These will, if you're not familiar with them, this should come extremely handy to you for pretty much any Python project that you use, even if they are not machine learning oriented. I know that MIT use Python, so I strongly recommend using Google Colab. If you're not familiar with a Python notebook, what a Python notebook is, so Python notebook or Jupyter notebooks, they allow you to write a Python code in what is called a notebook style with cells. So for example, in here I have a cell and I'm executing a Python code. So I have a very simple 1 plus 1. I could have I could just write a Fibonacci function. You can see that I'm writing a simple Python code here. Now, a cool thing about the notebooks is that you also have access to a machine behind it. So as long as you write an exclamation mark behind, you basically have access to the shell that is behind this machine. So it's you have basically a machine for free in the background. So in this case, for example, I can create a hello world file on the fly. If you're familiar with terminal, you know that with ls you can inspect the content directories, the content, the direct folder contents. So you can see in here that I see my files, and I can output back the file that I had before. Now Google Colab, it's a platform that gives you it's a free service. They also you can pay $10 a month as well, and they give you not only CPU but it's also GPU and TPU resources. What I use a Google Pro account. Is $10 per month. And what is really cool is that look at this. So usually these machines come between 12 to 25 gigs of RAM. It's funny. Usually they come with a 148 disk. Yeah. So for example, the machine that I'm using right now has a disk of 148, and in here, for example, I can select the runtime, and in here I'm using GPU. And like I said, I have access to a terminal, so I can use the NVIDIA commands, and I can figure out what GPU I'm using. And in most cases, you'll find out that they're using Tesla B100. If you go and search those in Amazon, the typical price for a Tesla B100 costs around $6,000. So in here, I have a machine that is very powerful with a GPU that goes for $6,000 for $10 a month. I would say it's a great deal. And the other cool thing is that it already comes with a lot of yeah, so are the files stored on a Google server instead of your computer? That's another great question. So the disk right now, this one is ephemeral. So if you store things in a disk and then I restart my runtime, I will lose it. But something that you can do, and it's pretty cool, is that you can also mount Google Drive. So you can mount a Google Drive and change the working directory to point to your Google Drive, and that way you will persist it. So actually what I typically do is that I mount Drive and I change the working directory. So whenever I'm training something, instead of using the disk that is provided by Google Colab, I'm writing into my Google Drive, and that way I persist everything. Thanks for your question. So now, the other benefit is comes with a lot of libraries already preloaded. In this case, we're going to be using a Tensorflow. You don't have to have the hassle of installing libraries. Everything is already loaded for you. And if there's a library you don't have it installed, install it is just a breeze. If you have used Python, you know that using it really installed. So in this case, we're going to be using TensorFlow to directly load our data set. Given that it's a toy data set, TensorFlow comes already loaded with it. So I already ran this code before starting the session, but it takes just a couple of minutes. You can, when you open the notebook, something you can do is you can just save a copy in the drive. And once you make a copy, all you have to do is just go here to runtime and run all, and you're going to be running all these cells, and you can run it on your side in just a few minutes. Now, I'm going to be a little bit more faster on this next step. So in here, I already loaded data set. You can see the digits. You can see that I have a data set of 60,000 images, each of them 28 by 28. And if I print the value of just one particular entry, you can see this thing. And that you can, most likely you can notice the 8 behind it. This is what the computer is seeing. And this is what we're going to be training to map to an 8. Now, to train it, we're going to be doing some data pre-processing. I'm going to skip this part for now. Perhaps the only thing to tell you is that I'm gonna renormalize the values. Instead of being from 0 to 255, you can see that 255 here. I'm gonna normalize them to 0 to 1s. That's easier for neural networks to train. You can see here normalized. And here's the machine learning thing. So I'm going to declare a very simple model. So in here, all I have to say is that the dimension of the input, which is the 28 by 28. And then I'm going to declare one hidden layer of another 28 by 28. And the output is going to be how many classes I have. So if you would like to visualize it, the 28 by 28 is 784. So there are 784 inputs, each pixel going in there. And then we have one hidden layer. If we go back to this, this example, in this example, I had two hidden layers. For digits, you can see that one hidden layer is actually enough. And like I said, the output, whenever you want to classify something, you have one node per output. And in there, I'll apologize. I know that there's a lot of details. It's not that complicated. My goal right now is to give you a high level insight or reasoning about how to train a model. All then it boils down to this part. So in here, once we have a model, we're gonna fit it. Fit it means training, which is the question that was being asked before. How do we know what weights there are there? And that's not something that we decide. That's what the machine learning algorithm tries to figure out. By training, it will try to figure out what are the each weight in here, what's the best value that maps best the set of inputs that we have into the outputs. So, and it's done by what it's called epochs. At each epoch is trying to find the weights, and it's kind of an optimization function. And at each iteration, this optimization function has a loss or an objective function, and we try to minimize this this function. You can see that the loss at the beginning was 0.27, and at each iteration that loss is reducing. And after a few iterations, we have a working model. When we evaluate it, it says that the baseline error is actually really low. In this case, it's less than 2%. So it's actually a pretty good, accurate model based on that data set. Now, once we have that model in here, we're still in the Python world. But today, I'm supposed to teach you about the web apps. And something very cool is that you can use TensorFlow, the JavaScript version. You can convert this TensorFlow model that we just built, and we can transform it to be used with TensorFlow. So this should be really helpful for your projects if you use machine learning. This is an example of a library that is not installed by default. I don't know why they should install it. But anyway, it's very simple to install. It's just to pip install TensorFlow. And what I have to do is I have my model here. And in one line, I convert it. Now, in this notebook, I also have access to the file system. When I run this line, it goes back here. It creates this folder model. And inside, you will find that there are two files, a JSON file and a binary file. The JSON file is the one that explains the hierarchy of or the network architecture that we defined. Namely, if you go back, is the one that this says how many hidden layers I had, what were the dimensions of it, and other parameters. And bin, the binary, are the weights, are those weights that this machine learning model was able to come up with. Once I have that, for simplicity, what I do is I just I zip that, and I have this model that zip. So what you can do in on your side is that, for example, you can download that model, and here will take just a few more seconds to download. But if you go and inspect the code, you can see that I have two things. I have the HTML file that has all the JavaScript. And in here, I have this model folder. So in here's where you would deploy, copy just that bin file in JSON file. And I'll show you things working in JavaScript. So you saw that I have this, this app here. So what I can do is, for example, I can go here. And so let's try to run a simple prediction. Actually, let me make sure that I'm following all the questions and yeah, how to import the data. Import the data, either you use TensorFlow typically has utilities to load existing data sets. But what you're going to be typically doing is you will have your own data set. And like I said, I mean, this is actually at the end of computer. You have curl available, and you can just curl it, or you can download it, for example, to your Google Drive and access it from there. Another question from Neha is, what does dense mean? I'm sorry. Yeah, dense means that it's a fully connected neuron. It's a way to call this guy. The reason why it's dense, it means that it's connected to everyone else at each layer. In the vanilla neural network, every node at each layer is connected to every other node at other layer. Yeah, the images are black and white. Fantastic question. Manas is asking, are there machine learning algorithms that change the number of hidden layers? Hidden layers, it's something that is a decision that you as a designer make. It's called a hyperparameter. Typically, machine learning networks don't automate that for you. Guys, you know what? I'll move on because I'm realizing that I'm running out of time. So I want to run this prediction again, but I want to show you how it's being, how it's happening in JavaScript. So remember this 8, right? So what I will do is I have the values already normalized here. So for that 8, so what I can do is I'm gonna copy those guys here. So I can put them now in JavaScript. So I have a variable called input. It's bigger. I already have a variable called input with the normalized values that I show you here. And bear with me. So in here, I'll copy this code and I'll explain what it's doing in a second. So what I'm doing here is that I'll show you how, but I already loaded my model in JavaScript, and I can ask it to on that input. This input is the values that we had before. We had to do some reshaping to put it back into 28 by 28. But the interesting things are the following. So you can see that we have a set of scores back. And basically the prediction is going to be the score that is the highest. In this case, you can see that I'm predicting back an 8. So I know it's still very, very quick, and I'm missing a bunch of details. But what I'm trying to show to you is that loading a machine learning model in JavaScript at the end is basically two things. Let me show you. So again, you have the whole HTML here. So actually, I would say 3 things. So the first thing is loading the library. So in this case, I have a script tag that is loading the TensorFlow JS library. And this one, perhaps the version is a little bit out of date, it doesn't matter. So 1, I load that the model. 2, I have to, sorry, first I load the library. 2, I have to load the model. And it's very simple. All I have to do is point it to the JSON file. So remember that I zipped that JSON file. If you put it in the same folder, all you have to do is point it to that JSON file. That JSON file will know also where you have to put the bin file in the same level, and it will pick up the weights. What I'm doing is I'm storing that into this global variable called window model for simplicity. And then you saw how now I can start running predictions. So very quick terms, sorry for how fast that things are. You can see that I took a data set, I ran it through a very simple neural network. I got a good results. I converted it to be used with TensorFlow JS. And now I can run it in JavaScript. And what this means is that I don't need any other server. I don't need to have another server running. This is something actually that we do often at Appian. We have already a few machine learning models. There are plenty of advantages of this approach. So one of the advantages is obviously you don't need an extra server running for this thing. Another, for example, cool advantage is that your data stays within the browser. For example, customers could be concerned that if I will have a separate service or a separate server where I run the predictions, if that data is sensitive, there's concerns that that data is going to other servers. So in here, the cool thing is that the data actually never leaves the browser, and I can run the predictions in the browser. Now, a couple of last things. So I used to draw something else that might be helpful for your competition. I'm using an HTML5 component called Canvas. Gosh, I don't know if I will be answered. What I will do is I saw you have a bunch of questions, and I think all of them are actually very good. I'll follow up with people and find ways to get back to you. I can answer them later tonight. Those are great questions. I'm using HTML5 Canvas to render. You have the whole code there, but I'll show you here very quickly the algorithm. So very simple is on mouse down, you attach an event listener to a canvas. And you say on mouse down, just basically start painting. I'm sorry, I'm skipping still details, but you have the code available to you. But on mouse down, you can just say start painting. Obviously on mouse move, just keep drawing. On mouse up is when it gets a little bit more interesting. So on mouse up, what I have to do is I have to draw a new image of 28 by 28 to scale it down. Remember that the input to this neural network was 28 by 28 pixels, and this thing is certainly larger than 28 by 28. So we draw it again. That's why you can see a copy of that number here. That's why you have the number up there. So you draw it again. And with that, I can extract the data again. It's a trick to scale down the image. And I have now the image in 28 by 28. Now, the other interesting thing is that the image that you're seeing here, it's in color. So if I ask for the data, it will return me an array of 4 elements. The elements for red, green, blue, and A stands for alpha, or the transparency. And in here, a trick is that given that the color is blue, we only take the blue channel. So that's why when you see this loop, you can see that I'm doing a +4 every time. And the last step is what I showed you before through the console. So I take that data and I just run it through the prediction model. And a couple more things. So you can leverage GitHub pages to deploy HTML. I know that in previous competitions, most of you use Heroku. Heroku is great for when you do need a server. The cool thing of GitHub pages is that if you create a repository following a certain standard, namely that you have your username and ends up in GitHub IO, whatever you deploy in here, you can access it. You can access it as a HTML server. That's actually a very cool service that GitHub provides to you for free. And And in here, I'm just going to talk high level about these other applications. So I have another application that in here, I'm just going to say high level. So I have another machine learning application that is, they can also access here. So this thing is, I have an algorithm called AlphaZero deployed in JavaScript in the same way that I deployed the previous one. And AlphaZero, it's a reinforcement learning algorithm that is capable of beating world chess champions and world Go champions with training time that is really, really low. And the cool thing here is that if you inspect the code, if you read this blog post, I implemented that algorithm in plain JavaScript. So if you're familiar with JavaScript, you should be able to follow this post. I know that I need a couple of minutes to leave to Julia, and let me start taking a look at the at questions. Julia, are you there?
Yep, I'm here.
Hello. Oh, Juliet. Sorry, I didn't know if it was
Okay.
Juliet.
Easy. The other member of my team is Julia, so
Yes.
very confusing. Well, hello everyone. I'm Juliette Wilson. I'm a campus recruiter here at Appian. I've been with Appian for about 2 years now, and I've been recruiting specifically at MIT since then. So we do have quite a few opportunities open for 2021, and of course it's never too early to start looking for internships for 2022 either. So I'm going to leave my email in this chat. I wish I could stay after for a breakout room, but I'm unable to do that this afternoon. So I'm going to give you my email. If you are interested in any Appian opportunities, all of them are listed on our careers page. We currently have full-time software engineer positions. We have a full-time technical consulting role. We have internships in software engineering as well as strategy analyst. We also have some quality engineer internships and full-time quality engineer positions open as well. But that's a little overwhelming to just list out. So I will leave here in the chat. Please copy and paste, save, and email me accordingly. My email is juliet.wilson@appian.com. And you can find our openings at appian.com/careers. And you'll just filter by university recruiting. You'll see that as an option once you go to our careers page. But if you choose to apply, if you'd like to connect on careers or resumes, anything like that, I'm very available, especially to all MIT students. We are actually doing on-campus interviews next week as well. So please, please, please send me an email if you're interested in. We'll funnel you into the correct route from this point. But I will let Carlos take over some more questions. It's really great to be here, and I hope you all will follow up.
Thank you.
Have a great rest of your Monday, everyone.
It's very impressive how many questions you guys have. I already made a copy of the questions, and what I can do is I can coordinate with Nico and find a way to just write an answer to all these and send them back to you, so I don't consume more of your time, if that's fine. Is that okay?
Yeah, I was gonna say, I know we have another lecture after this, but if you want, I don't know what your time is like, but if any students have any questions, maybe we can put you in a breakout room for like 10 minutes, however long you want to stay. But if you have something after this, that's totally fine. We can, I'll work with you to get the questions back to the students. Just
run to, but look, I mean, I have my email there. I already made a copy of all the questions, so I can type answers. And what I encourage, where would like to follow up, reach out to me via email with either questions or comments. Be more than happy to chat with you.
Yeah, thank you so much. Can we just get like a virtual round of applause for Carlos? Or if you want to unmute, you can also. Thank you, Carlos, for joining us. And Carlos will also be one of the judges that will be evaluating your websites at the end. So if you have any other questions, feel free to reach out to Carlos directly. You can reach out to me and I'll put you in contact with Carlos or Julia if you have a recruiting question. I think
that's so much.
Yeah, but thank you so much. Yeah, thank you so much.
Thank you, and good luck in your competition. Bye, everyone.
Thank you.
Great.